Hello everyone and welcome back. Today we are getting hand-on with some cool descriptive statistics in R. Don't worry, I will walk you through every step like we are figuring this out together. So let's jump in. Okay, we are starting with the empty cards data. So we are sitting with the empty cards dataset. It's like the OZ dataset for our learners. 32 cars, a bunch of starts, and a whole lot of fuel efficiency dramaless. And here str function gives us a quick peek at the variables, and head empty cars function shows the first 6 rows so we can see what we are working with. So let's run this code and see here. This is our result. See, we have got mpg for miles per gallon, cyl for cylinders, and a bunch of other cars. It's look good, right? Let's cross some numbers. So first off, the mean. It's just the average, nothing fancy. Then there's the median, the middle value. It's a great when we are outlier trying to mess this thing up. And for this model, we have to whip up our own title function since R doesn't do it out of the box. So let's run this. And you're seeing here, this is our mean value, this is our median value, and this is our mode value. Here the mean is the average MPG of our go-to number for overall efficiency, and the median gives us the middle ground, super handy for real world data. And the mode, that's just the most common value, not always crucial but nice to know. Now we are taking range and standard deviation and the variance. Here the range function gives us the smallest and biggest values, and the variance tells us how spread our data is, and the standard deviations is like the spread out but easier to wrap your data around because it's in the same unit as the data. So just run this, and you're seeing here, this is our range 10 to 33.9, and this is our variance, and this is our standard deviation. And here, just look here, we just use here empty cars data set, and we just calculating the MPG. And here we just calculating the MPG from the variance of MPG from the empty cars. And we also calculated here standard deviation of MPG from the empty cars data. So now, next, we are going to summarize the MPG. Here, the summary function is like a stars bucket, minimum, maximum, mean, and quartiles all in one place. Then we have got the IQR, which is the spread of the middle 50% of data, fancy, right? So let's run it and look at the result. This is the minimum for the empty cars data of MPG, and this is the first quartile, this median, this mean, this third quartile, and this maximum value. And this gives us a IQR of the MPG from the data set. If the IQR is small, our data is cozy. So it's time to visualize the fun stuff. And for that, these are our following code. Just use here this code for the histogram, this code for the box plot, and this code for the density plot. And we use also here the MPZ from the empty cars, and we use here histogram of MPZ for the title, and XLab MPZ, and YLab sky blue, and so on. So just run this and look at here. This is the plot for histogram of MPZ, and run the box plot, and this is the box plot of MPZ, and run this plot, and this is a density plot of MPZ. Let's see how these variables are playing together. Actually, we are going to finding the relationship between these variables, and for that this is the following code. Pairs, empty cars mean scatter plot of the matrix. Just we are using here the scatter plot of the matrix for the pairs, and this is for the core plot of the matrix. We just use here for the correlation, and we are looking to visualize the correlation into a plot. For that, this is we need core plot library and then core plot matrix. Just run it, and you're seeing here this is our core plot matrix. This showing us the relationship between the variables. If I edit this by lower, and you're seeing here this is the look, and if I edit this as full, it will show us this kind of core plot. So next, what if we want stats for specific groups like cars with 4, 6 and 8 cylinders? Easy groups them with defilier and calculate the mean and median for each group. And for that we need a defilier for library, and we're just grouping by COYL, and for that this is our results. The results showing us the turnouts, fewer cylinders, usually mean better fuel efficiency. Makes sense, right? Finally, let's talk about skewness and kurtosis. Skewness tells us if the data leans to one side, and kurtosis checks if it's pointy or flat. So just run this. You're seeing here this is the value for skewness, and this is the value for kurtosis. And that's it. We explored central tendencies, variability, relationship, and visualize it all. Descriptive stat in R isn't just easy, it's actually fun. Don't forget to practice. And that's for today. Thanks for watching. See you next. Bye bye.